In this section we have been talking about polynomials. Today we're going to determine the equation of a polynomial from its graph. I have an example here. I've drawn a graph of a polynomial. We're going to find the equation to this polynomial. First, we want to look at the zeros of this polynomial. The zeros of a function are the x-intercepts of the graph of the function. So the x-intercepts of our graph are where the function touches the x-axis, which is at 0, 1, and 2. So those are our x-intercepts and our zeros. Step 2, we're going to look at the multiplicity of our zeros. So if the graph crosses the x-axis at the x-intercept, then the multiplicity of a zero is odd. Do we have any that are crossing or going through the x-axis? We have 2. We have 0 and 2. 0 and 2 cross the x-axis, so they have an odd multiplicity. If the graph touches the x-axis at the x-intercept but does not go through, then the multiplicity of a 0 is even. So we have one of those, which is 1, and that one has an even multiplicity. And step 3, if r, we're going to look at the possible factors. So if r is a real 0 of f of x, then x minus r is a factor of f of x. So we have our 3 zeros. Since 0 and 2 are zeros of odd multiplicity, we're going to have x minus 0, which is just x. And I'm using our odd multiplicity, so as our odd power, I'm just going to use 1 because that's the simplest odd power. And then for 2, the 0 of 2, we're going to have x minus 2 as a possible factor, and I'm still using just a 1 power for odd multiplicity. And since 1 is a 0 of even multiplicity, our possible factor is going to be x minus 1 squared. I'm using a 2 for the even multiplicity, and it's the lowest even number. I could have used a 4 or a 6, but I wanted to use 2 because it's easier to use. And then the fourth step, we're going to look at the degree of the polynomial. If a graph has m turning points, then the least degree the function could have is m plus 1. So we have 3 turning points in our graph. So the degree of the function must be at least 3 plus 1, which is 4. And step 5, we're going to actually put our polynomial together. So when we are multiplying the possible factors of f of x together, so we're going to multiply, our first one is x, and we have x minus 2 as our second possible, and x minus 1 squared is our third possible factor. So let's rewrite this to be x minus 2, and x minus 1 times x minus 1, because square just means you're multiplying by itself. And then I'm going to multiply out the x minus 1, so we're going to x minus 2 times x squared minus 2x plus 1. And now I'm going to multiply these first two together, so we're going to get x squared minus 2x, and this is going to be multiplied by x squared minus 2x plus 1. And now let's multiply them all together. We're going to get x to the 4th minus 4x cubed plus 5x squared minus 2x, which is a polynomial of degree 4. So we have at least a degree 4 polynomial. So this polynomial is a possible equation to the graph above. So we're going to have f of x equals x to the 4th minus 4x cubed plus 5x squared minus 2x as our answer. And like I said, we could have different answers because we could make our even multiplicities 4 or 6, powers, or odd multiplicities of 3 and 5 power, but using the simplest one of the power of 1 and the power of 2 makes it a lot easier, and that is our answer.